dengan Dr. Azahan bin Abdul Rahman and T.S. Ahmad Subir bin Jamil. I am Muhammad NAJMI bin Abdul LATIB from 4BEUY. My bachelor's degree project title is Prototype Submersible in Pipe Pico Generator for Low Strain Fluid. Let's start with my project introduction. Pico is a term used to represent a small property, particularly in relation to the size of the mechanism. The prototype of the Pico hydrogenerator system was intentionally designed for installation in a domestic water pipe. The project simulation design is about generator to produce 5-watt power and 5-watt output by using Submersible RNXPRT software. Besides that, Pico hydroturbine can also have reduced carbon dioxide emission by replacing fuel and firewood, which contribute to the decreased exploitation of local resources such as reducing dependence on import fossil fuels, saving forests from destruction and soil erosion, reduce the number of house fires, and also can provide energy to load. For the objective, basically I have three objectives for this project. The first one is to develop a set of generators that can produce electricity by using low strain fluid model. To design a generator, the second one is to design a generator by using Submersible RMXPRT software. The third one and the last one is to produce result simulation by using different flow speed of water. Next is the research methodology of my project. From the figure below, shows my design for brushless DC motor in simulation and the design for the winding pipe. For the brushless DC motor design, there is consists four part that is stator, rotor, winding, and end fed magnet. In stator, there is also a slot for winding wire, and around the rotor will be placed an fed magnet. The winding also has three phases. The result and discussion that I have gained from my project is, as you can see on table 1 is my result for the three different speeds. The first one is for the starting speed, the second one is the speed for the maximum output power that I have achieved, and the third one is the speed when the maximum power is achieved but the speed is still increasing. From the output power graph, you can see the output remain constant after 900 rpm. This is because the motor has achieved maximum output. Then for the efficiency, 1500 rpm is the highest, but the output power will be constant and remain constant after 900 rpm. You can see in the screen about different effectiveness at figure graph. For 15 speeds that have been simulated, the efficiency will be differ for different speeds, and the 100 and 200 rpm, the efficiency is 0 because the motor cannot produce output for the lack of speed. For the figure graph about power, it shows the output start at 300 rpm because of 100 rpm and 200 rpm is lacking speed to produce output. The graph shows different output power for 100 rpm till 900 rpm, and it will stay constant after 900 rpm. The second graph is about efficiency for 15 different speeds, 100 rpm till 1500 rpm, and the graph shows the efficiency at the highest is at 1500 rpm. Although the efficiency at 1500 rpm is the highest, it will bring negative effect to the motor because the maximum output have been achieved at 900 rpm speed. The negative effect is such as the motor will become hot faster and it will greatly affect the lifespan of motor. As a conclusion, the simulated brushless DC motor will generate a variety of output including power, induced voltage, efficiency, torque, and many others. Based on the outcome and data analysis, it is possible to infer that the project execution accomplished the design objective. That's all from me. Thank you. For this video, I will demonstrate and explain about my simulation design. As you can see on my screen at the left side, there is a project manager with a listed part for the LTC motor design for my design. The first one is the machine. You need to select the machine type and you need to input the data at the required, such as the machine type is a brushless permanent magnet motor, and the number of poles is 2, the rotor position is inner rotor, frictional loss, reference speed, and the circuit type. This is the circuit type. I choose the white type 3-phase. Okay. The second one is the stator. This is the stator, and this is the slot. The stator, you need to input the outer diameter for the stator, inner. This is the outer diameter. I put 200 mm. The inner diameter 110 mm. The length is 50 mm, and the material type is steel. The number of slot is 9 slot. This is the slot, and the type of slot is number 4. For the winding, there is 3-phase winding because I choose the 1-phase 3-phase, the wide circuit 3-phase. This is the 1-phase coil, the 2nd-phase coil, 3rd-phase coil. For the rotor, this is the design for the rotor. For the outer diameter, for the measurement of outer diameter is 108 mm, and the inner diameter for the rotor is 40 mm, and the length for the rotor is 50 mm. The same material type as stator, steel type, and the pole type is the type 1. The end-type magnet will be placed around the rotor. Next, I will show you about analysis result. 15 results that I test from 100 rpm to 1500 rpm. From the table, we can see that 100 and 200 rpm is no output power and the efficiency. I will prove to you. I will simulate for 100 and 200 rpm, and then the starting for the motor that produce output power and the maximum output power, and after the maximum output power have been achieved, what if the speed is still increased? Okay, the first one is 100 rpm. We need to simulate this first. We need to analyze. Okay, for the full load, As you can see here, it has error because breaking speed, so the motor cannot produce the output power for the full operation. As you can see, the output power is 0 and the efficiency is 0%. This is because this motor can offer the given rated output power. For the second one, when the motor is produce starting for 300 RPM, the output power is 0.8 watt and the efficiency is 2.87%. I'll show to you the output power that this motor can get. This is more output that this motor can produce. As you can see, the output power is limited to 5 watt and the efficiency is 26.2491. There is also the curve for the efficiency, output power, output torque, and many more others. You can see the result at my table, at my report, for the speed, induced voltage, efficiency, power, air gap, and torque. Okay, the last one is for the when the motor have been achieved the highest maximum output power. What if the speed is still increasing? Operation. Okay. The output power is 5 watt, but the efficiency is increased from the 900 RPM. It's 6.25 and 5 watt, and it remains constant after 900 RPM. That's all from me. Thank you for watching and thank you for listening.